Okay, so up until this point, when we've been talking about solving systems of equations, we have been just looking at where lines cross. But we know that lines don't always cross, right? So just like when we talked with inequalities, we're going to have some special cases where we're going to have no solution and many solutions, or infinitely many solutions, when we're dealing with systems of equations. So this should just be a review, but when we're talking about parallel lines, what I'm talking about are lines that don't cross. Lines that never cross. Something else that I know about systems of or parallel lines is that parallel lines have the same slope, right? And if it's helpful to have a visual, right, parallel lines just means that they're going at the same slope and are next to each other. They never cross. So that should just be a review. We know about parallel lines. The new vocab term then is consistent. I can have what's called a consistent system of equations. So a consistent system of equations is essentially when I have one line on top of another, or essentially what I'm just saying here is that it's the same line. So what that means over here is that I would have the same slope like I do with parallel lines, but I would also have the same y-intercept. And this might be a little bit harder to visualize, but here's what we're doing, right? Here's my initial line, and then I would have a line on top of it, something like that, right? So I've got two separate lines, one just right on top of the other. Okay? So I can graph solutions. That's one way that I can figure out the solution to a system of equations. So the first one that we're used to is I can have one solution. So if I have one solution to my system of equations, that means that I have two lines, they intersect somehow, and my one solution is where those two lines cross, right? It happens right there. It's where those two lines cross. So that's when I have one solution. I could have no solutions if when I'm looking at a system of equations, the part that I care about, right, is the part where the lines cross. So if there's no solutions, that means there's no point at which my two lines cross. So this is the case where I would be dealing with parallel lines. There's going to be no solution because they will never cross. I can also have many solutions or infinite solutions. If I have many solutions, that's the case where I'm going to have one line here, and then I could have another line right on top of it. And this makes sense, right? Because if we're thinking about this, many solutions is however many places they intersect. If one line is on top of another line, it's constantly going to intersect. So it's just going to go on forever. So here's kind of the nice thing about what, when we're looking for the number of solutions that a system of equations will have, is if I'm dealing with two just straight lines, if I get them in slope-intercept form, so if you remember slope-intercept form, slope-intercept is where we have y equals mx plus b, where m is our slope, and b is the y-intercept. If it's in y equals mx plus b, we can just compare the two equations and figure out how many solutions there's going to be. So if I have no solutions, what that means is that my lines are parallel, right? No solutions means that I have parallel lines. Well, I know that parallel lines have the same slope. And in order for there to be no solutions, they would need to have a different y-intercept. So same slope, different y-intercept. If there's going to be one solution, I'm going to need a different slope anytime that I have a different slope. 100% of the time, my lines are going to intersect. If there's a different slope, they will intersect. So the slope needs to be different. The y-intercept doesn't matter. for this one. It can be anything. Doesn't matter. Okay, and if there are many solutions, that means that I have one line on top of another. So that would mean that it's the same line, right? So in that case, I would need to have the same slope and the same y-intercept. All right, let's move on. So I actually want to start with this one. So I have a necklace and a matching bracelet with two types of beads. The necklace has 40 small beads and 6 large beads and weighs 10 grams. The bracelet has 20 small beads and 3 large beads and weighs 5 grams. So I need to figure out a system of equations for each of these and solve. So if I'm looking at the necklace, I have 40 small beads, so we'll say 40x, plus another 6 large beads, so 6 times y, that's going to equal 10. Okay, that's my first equation. It's the equation for my necklace. The equation for my bracelet, then, I would do a similar thing. We've got, 20 plus 3 equals 5. So we're not really going to worry about graphing it. If you were to graph it, it would end up looking something like this. I'm just kind of, ooh, that was really bad. It would eventually kind of look like something like this for both of them. So here's what I really would like you to notice, though, is if I look from the necklace to the bracelet, I can either divide the top one by 2 or multiply the bottom one by 2, and I get the same equation. So what do we notice about the two lines? Well, they're the same line. And so then the question is, can we figure out the weight of each type of bead? Well, if we look at the system of equations, what is the solution? Well, if it's the same line, I know that there are infinite solutions. Because there are infinite solutions, I cannot know what the actual answer is. So, cannot find the weight of each bead. So here's kind of the thought process here, right? This maybe feels a little bit confusing because, like, well, Mrs. Olson, obviously we could weigh the beads individually and I would know what each bead weighed. And that is true, that's accurate. Mathematically speaking, with the information that we've been given, there is no way mathematically to figure out the weight of each bead. And if you kind of think about this in terms of reality, it does make sense a little bit. So if I were to have 40 small beads, if you just think of the little glass beads in a bowl, and I measured each individual bead, would they all be the exact same? The answer to that is probably not, right? They would probably not all be the exact same, so it kind of makes a little bit of sense in that case. All right, so I want you to try this first one then on your own. So you invest $450 for equipment to make skateboards. The materials for each skateboard cost $20. You sell a skateboard for $20. So we want to write a system of equations. So write an equation for the cost and the revenue, and then complete the table. I just want you to complete the table through 3. So just do 0, 1, 2, and 3. You don't have to do the rest of this. And then answer this question. So when will your company break even? And what feels wrong? What's wrong about it? So go ahead and pause this and then come back when you are ready to go. Okay, so here's what you should have done. So you should have had, my cost is going to be the $450 initially, plus $20 for every skateboard. My revenue, then, is just going to be $20 for every skateboard. So if I'm going to figure out my cost, So when I have sold 0 skateboards, my cost is still $450. I have made $0. After selling one skateboard, my cost is $470, and then I've made 20. So on and so forth. It would be $490 and $40, $510 and $60. So the question is, when will your company break even? Well, I would hope that it's pretty clear to see that you will never break even. Here's why, right? If we compare these two equations, here's what I've got. I've got 20x here, got another 20x here, right? So those match. I have the same slope, in other words. But then I also have this additional $450 over here. So what that means is that every single time I make a skateboard, I sell it for the same amount. But then I also spend an extra $450. So what that means is that my cost is always going to be $450 more than what I have made, which makes sense, right? If you make a product, you sell that product at cost, you are never going to make any money. That's the same thing that's happening here, except now we're just losing money every time. So you're never going to break even. Oops, that's not what I want. And I know that because these are parallel lines, which means no solution. You're never going to get to a solution. You're never going to break even. Okay? All right. The rest of this is practice, but I just kind of want to show you something with 1 and 2, and then I'm just going to have you do the rest on your own. Something to keep in mind when we're doing systems of equations like this. We are doing this the exact same way that we have been doing it from the beginning. You're still solving with substitution or elimination. Now we're just putting a little extra tools in our toolbox. So now instead of having to solve every single time, what I can do is I can compare slopes and I can compare the y-intercept, and that can tell me how many solutions I have. So if I look at number 1, right, I have y equals 3x minus 7, y equals 3x plus 4. Something that I'm noticing right away is if I'm looking at these in slope-intercept form, y equals mx plus b, that these two things have the same slope, and they have a different y-intercept. Well, I remember back here, I have this handy chart down here. I have the same same slope and a different y-intercept. That means that those two lines are parallel. So I'm going to come over here and I'm going to say, well, I know these are parallel. This is no solution. And here's what I would do if I were you. Because these are our notes and we get to use our notes on tests and quizzes, I would write that they're parallel lines. Here's why. If you're going back to this to look for examples, then you can look at that and go well, why did I know that was no solution? I know that's no solution because they're parallel lines, right? So that's one way to do this one. Here's a second way that we can do the same problem. So if you are just I can't remember what to look for, we can solve this the exact same way that we have been solving them. So this would be a good one for elimination, right? I would subtract these two to get rid of things. So I would have y minus y, which is 0, equals 3x minus 3x is 0. Negative 7 minus 4 is a negative 11. So now you should ask yourself, does 0 equal negative 11? This is not a trick question. The answer is no, right? 0 does not equal negative 11. That's not true. This is no solution. Let's skip over to number 3. I can do the same thing. Over here, if I want to cancel these out, I'm just going to add these two things together. 2 minus 2 is 0. Negative 3 plus 3 is 0. 10 minus 10 is 0. I have 0 equals 0. Same kind of question. Does 0 equal 0? The answer is yes. Does 0 always equal 0? The answer is yes. This is going to be many solutions because 0 is always going to equal 0. It's always true. so it's going to be many solutions. Okay, so go ahead and do the rest of these on your own. If you have questions, feel free to ask me.